Hello and welcome to our lesson on fractions of a circle. In this lesson, we'll expand our previous knowledge of circles by learning how to handle shapes formed when a circle is divided. We'll start by familiarizing ourselves with the new vocabulary for divided shapes, including semicircles, quadrants, and sectors. Next, we'll explore how to calculate the area of these divided shapes, applying our previous knowledge of the area of a circle. Then we'll look at how to determine the perimeter of these divided shapes using what we know about the perimeter of a circle. Finally, we'll run through some practical examples to solidify our understanding and see how to apply these new concepts in various problems. So far, we have covered how to use the formula pi r squared to find the area of a full circle. We also covered how to calculate the circumference of a circle using the formula 2 pi r. With this foundation, we can now introduce the concept of divided shapes and learn how to calculate their area and perimeter. This technique is crucial for tackling more complex geometrical problems and shapes. For instance, if you need to determine the area of a semicircular garden bed or the perimeter of a quadrant-shaped artwork, this knowledge allows you to handle such tasks efficiently. Let's get started and explore these fascinating shapes. Before we get into calculations, let's familiarize ourselves with some key vocabulary for divided shapes. First, a semicircle is a shape formed by dividing a circle into two equal halves. Second, a quadrant is a shape formed by dividing a circle into four equal parts, each representing a quarter of the circle. Finally, a sector is a portion of a circle enclosed by two radii and the arc between them. The size of a sector is determined by the angle at the circle's center. Also note that a semicircle and a quadrant are both types of sectors. A semicircle is a sector with an angle of 180 degrees, whilst a quadrant is a sector with an angle of 90 degrees. Therefore, whilst we will learn formulae for semicircles, quadrants, and sectors, you can always find the answer for all of these cases just using the formula for a sector. Now let's turn to calculating the area of divided shapes. First, let's look at a semicircle. Since a semicircle is half a circle, finding its area is quite intuitive. You use the area formula for a full circle and then divide by 2. This gives the following formula. Area equals half pi r squared. Moving on to a quadrant, to find its area, you use the full circle formula and then divide by 4. This gives the following formula, 1/4 pi r squared. To find the area of a sector, you need to know the angle of the sector, let's call it theta, and use it to determine what fraction of the circle the sector represents. Specifically, we divide theta by 360 and multiply this by pi r squared. For example, if the sector has an angle of 60 degrees, then we substitute this into the formula to find that 60 degrees out of 360 degrees is 1/6. So the sector makes up 1/6 of the whole circle. This means that the area of the sector is 1/6 pi r squared. Let's now move on to considering the perimeters of these divided shapes. First, a semicircle. The perimeter of a semicircle consists of half the circumference of the full circle plus the diameter. This gives the following formula, pi r plus 2r. Onto the quadrant, the perimeter of a quadrant includes 1/4 of the circumference plus the 2 radii. 1/4 of the circumference is a quarter of the full circle circumference, 2 pi r, so it is therefore half pi r. Each radii is r, therefore adding them together, we get 2r. So the perimeter of the quadrant is half pi r plus 2r. Finally, these two cases generalize to the formula for a sector, because remember that a semicircle and a quadrant are both sectors themselves. The perimeter of a sector includes the arc length of the sector and the 2 radii. The arc length is determined similarly to the area. We use the angle theta to find out what fraction of the whole circle we have. Then we multiply this by the circumference of the circle to find the length of the arc. So we get theta out of 360 degrees multiplied by 2 pi r. Again, we have two radii, each measuring r, so the two of them together gives us 2r. Therefore, the perimeter of the whole sector is theta out of 360 degrees times 2 pi r plus 2r. For example, suppose the sector has an angle of 60 degrees. To find the arc length, calculate 60 out of 360 to find that the sector is 1/6 of the circle. This means that the arc length is 1/3 pi r. Therefore, the full perimeter of the sector is 1/3 pi r plus 2r. With this understanding of vocabulary and techniques, you can now efficiently calculate the area and perimeter of various divided shapes like semicircles, quadrants, and sectors. Let's apply what we've learned to a practical problem. Suppose we have a sector with a radius of 5 centimeters and an angle of 90 degrees. Remember that we call this type of sector a quadrant. Pause the video and see if you can calculate its area and perimeter. To find the area, you can either use the formula for the area of a quadrant, or we can use the more general formula for the area of a sector. For this example, we will use segment formula, but practice this question using the quadrant formula to show that you get the same answer with both. The formula for the perimeter of a segment is theta over 360 times pi r squared, where theta is the angle. Substitute this into the formula. Then simplify to find that the area is 6.25 pi cm squared. Now let's look at the perimeter. Again, we can either use the formula for the perimeter of a quadrant or the more general formula for the perimeter of a sector, because remember that a quadrant is just a sector with a 90-degree angle. In this example, we will practice using the sector formula, which finds the arc length and then adds the two radii. But you would get the exact same answer if you used the quadrant formula. Sub in the angle as 90 degrees and the radius as 5 centimeters into this. Simplify this to find that the perimeter is 2.5 pi plus 10 centimeters. By working through examples like these, you can see how to calculate the area and perimeter of divided shapes like semicircles, quadrants, and sectors. In today's lesson, we explored the fascinating world of divided shapes such as semicircles, quadrants, and sectors. We began by introducing important vocabulary, defining a semicircle as half a circle, a quadrant as a quarter of a circle, and a sector as a portion of a circle determined by a central angle. Next, we delved into calculating the area of these shapes. For semicircles, we used half the area formula for a full circle. For quadrants, we took a quarter of the full circle's area. For sectors, we determined the fraction of the circle represented by the central angle and used this fraction to find the area. We then turned our attention to finding the perimeter of these divided shapes. The perimeter of a semicircle included half the circumference plus the diameter. For quadrants, it was 1/4 of the circumference plus the two radii. For sectors, the perimeter consisted of the arc length, derived from the central angle, and the two radii. By mastering these techniques, you can efficiently handle various practical problems involving divided shapes, from garden designs to artwork. This foundational knowledge enhances your understanding of geometry and equips you with valuable problem-solving skills.